So Doctors Lynne Wilkens and Dr. Samuel Antwi.
Hi, I'm Lynne Wilkens. I'm the current chair of the steering committee for the Cohort Consortium, and I'm a faculty member at University of Hawaii. And I'll be moderating this session along with Dr. Sam Antwi, and he is an assistant professor at Mayo Clinic College of Science and Medicine. And I will turn it over to him to introduce our first speaker.
Hello, my name is Sam Antwi, and I have a privilege of introducing Mr. Sean Coady of the National Heart, Lung, and Blood Institute. Mr. Coady is an acting deputy branch chief in the epidemiology branch of the Division of Cardiovascular Diseases at the National Heart, Lung, and Blood Institute. He has been at the NHLBI for 22 years and has managed the data repository for nearly 20 years. Mr. Coady also maintains a grants portfolio composed primarily of training awards and R01 grants. He's also the project scientist for a project titled Risk Underlining Rural Areas Longitudinal Heart and Lung Study. Mr. Coady is also serving as the program lead in the Institute's cohorts for COVID-19 research initiative. I'll now hand over to Mr. Coady for his presentation.
Thank you very much for that. So what I thought I'd do is just kind of give you an overview of the NHLBI experience and widely sharing data from its clinical studies. Next slide. So basically the website or the data repository really opened up in 2000 with a very simple purpose. And that was that the Institute felt that in order to take full advantage of the investment that had been made in some of its clinical studies and to really maximize the research value, that we should really make that data widely available, respecting participants' informed consent choices, as well as maintaining a strong stewardship program for the Institute to as wide an audience as possible. So next slide. So as the data repository, in addition to the data repository, the Institute also supported a biorepository. And they were both kind of managed independently, but over time, there was greater overlap between the two repositories, and it really kind of illustrated the need that we needed some greater coordination between the two. And so thus, BioLINCC was established in 2009 to really act as that coordinating center and to really put in a user-friendly front end for our data sharing, for our wide data sharing efforts. Next slide. So in terms of the current portfolio in the controlled access portion of the data repository, we currently have around 54 observational studies and 170 trials. And in terms of the type of studies that you'd find in the repository, it's what you'd expect from a heart, lung, and blood institute. We have our asthma trials, our cardiovascular trials, transfusion trials, kind of, et cetera. And next. And just to kind of illustrate where our general population cohort studies and our race ethnicity specific cohort studies are, just in terms of the number of studies or the proportion of those studies within the portfolio, you can kind of see their relative proportions right there. Next. So in terms of utilization of the data repository, you know, as you can kind of see early on, we had a fairly steady but you know, low but steady growth in the data repository. But especially since around 2016, there's really been strong growth in demand from the data repository. You know, really probably as a result of greater acceptance of secondary analysis from studies within data repositories, and a greater awareness, you know, that type of thing for data sharing. Next. So in terms of utilization, so this is one way of looking at kind of utilization within the types of studies that we have, using kind of the notion of the observed number of data access requests relative to what might be expected based on the proportion of those studies within the portfolio. So if a type of study is 10% of the portfolio, then you'd kind of expect that then the number of data requests would be about 10% of your overall data requests. So anything with a ratio greater than 1 kind of indicates stronger demand than what we might have expected. So looking at this, of course, our general population cohort studies and our race ethnicity specific cohort studies, they, they're designed from the outset for to try to address a wide range of questions. So it's not unexpected that you'd see kind of ratios greater than 1 here, but other types of studies such as respiratory distress or the heart failure trials, this is kind of illustrating, some high demand in certain types of studies, certain other types of studies as well. Next slide. So one thing that observed over expected ratio doesn't really address is kind of the amount of time a study has been available. So this is another way of kind of looking at the same type of data, but adjusting for time. And here we're adjusting for, we're looking at kind of 2 relatively recent time periods, the lighter blue being 2013 to 2015, and the darker blue being 2016 to 2019. And again, you can see with our general population studies, both strong overall demand and but also, there's been kind of like no abatement in that demand. But again, here we see respiratory distress and heart failure in particular as being 2 areas of kind of strong demand as well overall and strong growth. And to me, this kind of points out, some areas where the Institute itself might be considering where there could be gaps in its funding, in areas where we're really generating more questions than we have data to answer. Next slide. So some of the reasons for going to the data repository, as you can see in that blue color there, the most predominant reason is for new hypothesis generating research questions. And that's been the predominant reason throughout kind of time here. But some of the other major reasons include proposed meta-analyses, research into statistical methods, how we conduct clinical trials as a comparator group. And then in that kind of orange shade, more recently within clinical prediction or primary prevention risk prediction are strong areas of kind of reasons for demand. And then the other kind of just areas can classify into those other 6. Next slide. So another question might be, how long does a study data set kind of sit in the repository before it gets a first data access request? And as you can kind of see here, about 50% of the studies that we have at least 1 data access request within the first roughly 6 to 9 months. And then the vast majority of studies will have at least 1 data access request within the first 3 years. Next slide. So in terms of outcomes, of course, publications, being the one outcome metric that you can't escape. And as you can kind of see here, there's been, reasonable kind of growth in the publications. Hard to tell if this is really what we should be expecting given demand, because of the time lag type of factors between getting the data and publishing, but still reasonable growth in the number of publications. Next slide. So how long does it sort of take before a study data set from the time it's kind of released or made available until there is a publication? As you can see here, these are about 25% of studies will have at least 1 publication within the first 3 years. And if we kind of like flip it in terms of how many investigators actually end up publishing, we see kind of something roughly similar. About 20 to 25% of investigators publish within the first 3 years as well. Then as you can kind of see here that in terms of the investigators that do publish, the average that we have at least so far is around 3 publications per investigator publishing. Next slide. So another outcome metric that we really don't have a good handle on, I think, is the role of a data repository in workforce training. And we do know from our data access request that about 23% of those indicate that the primary user has 0 to 5 years of research experience. I did a little QVR search of NIH grant applications, and I really found only 2 that specifically mentioned BioLINCC as kind of like a primary factor within their training application. Next slide. But sort of another way to try to look at this was to look at what's in the funding acknowledgement of publications, although, you know, not everybody publishes. But among all of our publications, about 41% indicated some funding support for that publication. And then among that 41%, again, 41% of those indicated a training mechanism, an NIH training mechanism, as being at least one of the funding sources for the publication. Next slide. So one thing I kind of wanted to review fairly quickly was just the data sharing model that we have for our ongoing population-based cohort studies. And this is using Framingham as an example. So over in that kind of light blue box, you know, Framingham will share data both internally, like the folks in red there, internal investigators, but they also share externally through internal study processes, through things such as the publication committee or ancillary studies committee. So they, you know, they share as well, and then simultaneously they're depositing their phenotypic data into the data repository, which of course is widely sharing. But Framingham doesn't play a role in the analyses or the publications that emerge from the data repository. So next slide. So keeping that kind of model in mind, one thing we looked at, and this is actually kind of a somewhat dated analysis, but we tried to compare the publications, the phenotypic publications. So we tried to look at this in an apples to apples way. The phenotypic, well, our data repository doesn't have the genetic data. The genetic data goes to dbGaP. So I'll just kind of clarify that real quick. So we tried to compare the phenotypic publications that emerge using internal study processes from those that came from the data repository on the red. So these categories here were based on the Thomson Reuters categorization of the journals. But in comparing this, you know, you can see quite a bit of overlap in terms of, you know, they're both widely publishing within, say, the cardiac and cardiovascular systems domain. But we can also see kind of spikes within the data repository side. So, you know, the potential for publications that may not have been done otherwise, kind of in particular within the urology and nephrology field, and then as well as within the respiratory field. So actually that's all I have. And with that, I thank you.
Great. There's one simple question before we move to the next presentation. There's a question about publications per study per year.
Okay. That first slide, you think, the one with the, so that was publications within that year.
Okay, thank you.
Thank you very much for that. And we'll have time for more question and answer at the end. So I'm going to now introduce the talk on order online for data sharing menus, self-service, and automated delivery in a California teachers study. And the speakers are Dr. James Lacey and Emma Spielfogel, and they Dr. Lacey is a PI of the California, multiple PI of the California Teachers Study. He is a professor of epidemiology at the city of, and professor and director of the Division of Health Analytics at the City of Hope. And he has a PhD from University of Michigan School of Public Health. And Ms. Spielfogel is a data analyst for the California Teachers Study, and is involved in the data sharing and data visualization, and we welcome their talk. Thank you.
Thank you, Lynn. Thank you, Sam. It's good to be with everyone again today. Before I start, I do want to recognize that all of the work that Em and I are going to present was funded by EGRP. And over the last couple of years in particular, the entire program and division chipped in to help make sure that the CTS succeeded. I do want to particularly point out the help that Dr. Tram Lamb, Joanne, Elena, Scott Rogers, Gary Ellison, Kathy Helselsauer, Bob Coyle, and most recently Samdat Mahabir contributed to the CTS. So we're eager to show you some new data sharing tools today. Next, please. This audience knows that getting data from a cohort to a cohort consortium project can be a painful experience. This is a quote from a recent publication describing the Maelstrom software. It's time intensive. We've seen it. This challenge of how can we get cohort data to cohort projects is one that keeps coming up over and over again. Next slide, please. We've been thinking about this a lot on the CTS, and for about the last 6 years, we've thought of these questions in terms of the feasibility and the analysis, the how do I and how can I. Almost every project, internal or external, in the CTS starts with data exploration. How do I find out how many cancers, biospecimens, combinations exist within the cohort? The goal of that kind of question is really to inform feasibility. Is it worth it to include our data in a particular project? On the right-hand side, then the goal is to get to analysis. If someone says, yes, let's go ahead and include it. How can we get the specific data that project, that consortium needs? With the goal there of really understanding, discovering, and publishing the results. Next, please. Facilitating analysis was really the goal of what a lot of you have heard about over the last couple of years as the CTS has moved from data sets to a data warehouse. A key role of our CTS data warehouse, and we described this in detail in a March 2020 publication, was to speed up the process of analysis, get all of our data into a data warehouse that was really designed to facilitate exploration and analysis. And for the most part, that has worked. What I do want to do before handing it over to Emma is show you a little bit more about the overall infrastructure. Next slide, please. And talk about one of the pain points and how we're going to try to solve it. As some of you saw yesterday, our overall infrastructure includes a public website, our study management platform, which grew out of our biobanking work, and then the controlled access data warehouse environment. Next, please. And each of these was designed for different users. Could you click 3 times, please? The website is really designed for the public, aggregate data, current collaborators, potential collaborators, participants can go there. Our internal team uses a study management platform, and on the right-hand side, all of our individual level data, all of our analytic tools and templates are in that controlled access environment with our data warehouse. Next, please. And could you click through 3 times, please? Different data and documentation are there as well. Thank you. The website has surveys, a lot of the things that are on your cohort's website. Behind the scenes in our study management platform is a lot of the work we do on engagement, which Kim and others talked about nicely this morning. And again, the controlled access environment includes a lot of the individual level detail in that controlled access environment that Sean talked about as well. Next, please. So if you want to use CTS data, the website is the place to go to request access, to review, study, summary information, to explore aggregate data. Next, please. If you want individual level data, that's really where our remote desktop and controlled access environment comes in. You can reach that through our website, but that's really where it is. Go ahead, next, please. The schematic in the middle shows that sort of data sharing challenge that I talked about. If you come to the CTS and say, I'd like to include your data, we ask you to complete a data request form, the green box on the top. We then receive that form. Some of you have done it. Currently, it's in an Excel format. And we take that information and we manually insert that into some SQL templates. Those SQL templates draw data right from our data warehouse, and then we manually deposit those files for you in our shared workspace, which you can then use. And of course, if the project changes, if you want to add additional variables, you have to go back and sort of repeat that process over and again. All that information documentation is in our remote desktop, which is good, but it could be better. Next slide, please. What we found is that those manual updates were a bottleneck for us. And we've talked about this for years. You know, for all of the benefits of aggregating the data, using a web-based environment, you know, we're still running into this bottleneck of having to manually create every single file. So what if we instead could find a way for our researchers and you, the entire community, to choose your own data? And that's really the motivation of the tool we're about to show you. Next, please. We're about to launch what we call a secure web application that's focused on self-service. The goal is to give the research community access to a secure website through our CTS public website, allow researchers to use that app to configure your project-specific data, and then have that app automatically generate and deposit the custom information you need within our secure environment. So get us, the CTS team, out of the business of manually creating data sets. I'm going to turn it over to Emma, who's going to walk you through some of the details. All yours, Emma.
Thanks, Jim. Next slide, please. So the app automatically generates 5 custom deliverables for each project. And these are a project-specific data set, which is read-only, and a formats file to make sure the correct data types are assigned, a PDF summary with the user selections, as well as a study population story that describes what the denominator is for that project and why. And then data calls in both SAS and R, a user can choose which they prefer, and both contain some starter code to help get them started, and a data dictionary that matches their data. Next slide, please. So now that you know what you get when you use the app, I'll walk you through the interface itself in a demo. So next to start that, please. This is the login screen where a user will type in their email address. So this is my email address. Then a user will see all CTS projects that are associated with their email address, and they'll also see some details about each project that they're a part of. And I'll be using lung cancer as an example, so you can click here to configure that project data. And the first screen that a user sees is Select Cancer Endpoint. So a user can click in this box and scroll to find their cancer of interest. So this is scrolling, or if they know what they want, they can instead just type in the box. So here we'll type lung and then select lung and bronchus. And once you've selected your cancer, a table appears which has the cancer site group, the SEER code, the ICD-03 site, the histology, and the total count of cancers in the CTS population. So a user can select all, or they can go in and select and deselect specific histologies and rows that they like. And then at the bottom, there's a total count of the cancers in the CTS population that meet their endpoint criteria. Then back at the top, there's this Summary Charts tab. We'll just take a second. And it updates to show the user selections. So we can see the total number of participants with cancers selected, as well as a chart of year at diagnosis by age at diagnosis. And then below that, we'll also see distributions of histology and stage for the selected cancers. We'll go back to select data, and the next step is selecting the start of follow-up. So on this screen, users select the analysis start date, which most often users will choose CTS baseline, but there's also the option to choose a later date or of one of the other questionnaires or a specific date of their choosing. And users also choose how they would like to treat prevalent cancers. So they can exclude all prevalent, they can include just prevalent of the cancer of interest, so here it would be lung, or they can choose to include everyone. And then the next step is to select censoring rules. Similar to the start date, a user can choose the end date, where they can choose everything we have available, or they can choose to stop follow-up at an earlier date. And then they also choose the censoring rules, so they can choose to either use the default CTS censoring rules, which includes censoring at diagnosis of another cancer, or they can choose to not censor at diagnosis of another cancer. And what's really cool is at this point, you can return to the Summary Charts tab. and see that all the numbers and charts are updated based on those choices. So the number of total participants decreased because we excluded participants with prevalent lung cancer. And we can now see that the charts are all updated to reflect the start and stop dates of 1995 and 2017. The next module will go to select questionnaire data. And we have over 1,200 questionnaire variables available here with a few different ways to look at them. So here you're looking at sections. These sections, such as background and environment, correspond to the section headers on the physical questionnaires that were given to participants. And you can expand each section to view the variables. So at the left, you see variable name, there's description, and then when you're hovering, you're actually seeing the values for those variables. And any variables you see that are in green are what we call the pre-selected variables, which means that users receive those automatically. So things like race and age, a user doesn't need to request, they'll just receive those, and they can select additional variables to include. And so there you see checking some boxes, and those will show up in that right panel. My selections will show all the variables that they've chosen. We can also look at this by searching. So since it's lung, you could type smoke in the search bar and then see which sections and variables are associated with smoke or smoking and look at it that way. And then the last option for a way to look at it is by topic. So say someone was interested in smoking and pregnancy, they can go to the topics view and filter it by the topic pregnancy and see kind of where those intersect. So they can see things like total years smoked before pregnancy. Again, before we go to the next step, we can look at the My Selections tab to make sure everything is there. And then on the last screen here, we see a summary of all of the user selections. So at the top, we have the cancer endpoint with the details about which histologies that they chose. There's the start of follow-up, the censoring rules, and the list of all questionnaire variables that they chose. At the bottom, a user will click Generate Data, which triggers the output of those 5 deliverables that I mentioned earlier into the secure remote desktop environment. So a screen will pop up like that. If we could go to the next slide, please. So this is what those deliverables look like. Once you click Generate Data, in a secure read-only output data folder, the project-specific data set is output as well as the formats file. And in the user's project folder, they receive their summary PDF, the data calls, and a data dictionary. Next slide, please. Our formal launch is scheduled for December 2020, though we have done a soft launch with one OC3 consortium project who they're using the in development version. The modular design you saw with the different screens accommodates other types of analyses and data. So we have plans to expand to other endpoints and analytic designs, and many of them will use the same modules, for example, selecting the questionnaire variables in combination with some new modules that we'll come out with. And we believe that this approach could improve CEC data sharing. Thank you.
Thank you very much for an excellent talk. We have one question. Oh, Jim, were you finished? Okay. We have one question for Emma. In the application, are the variables harmonized across studies, or does one study have its own set of variables?
So the idea would be that, as it currently is, this would allow analysts from data sharing projects to come in and look through what we have themselves and select what they need, and then they can harmonize that themselves is the current idea, as opposed to us needing to have that kind of bottleneck where we're going back and forth and they aren't getting to see exactly what their options are of what we have.
Okay. Sam, you want to ask?
Yes, there's also a question about the lag time between data collection and when the data is made available for use in the app. And that is to Emma.
Yeah, so between the collection of data, with respect to surveys, I think we're not expecting to have any more questionnaire data going to our participants. So in that case, I think it's not applicable. We do have the linkages to the state data on cancer. And so it is set up in such a way that we can update that data as soon as it's ready and push that to the app.
There is also another question about how much work you have to do upfront to get the data ready into the app. Do you have to categorize multiple variables? What is the details of getting the data into the app?
Yeah, we did do a, oh, go ahead.
Up to you, up to you.
I was just gonna say, we did do a lot of work up front to identify what variables should go in there and how they should be presented. But fortunately, I think it's, once you've done that lift up front, we can always make minor changes, but the bulk of that work, I think, has been done.
Yeah, I'll add just one thing, and this is not strictly a plug, but Lynn, I think we do have another webinar coming up on data sharing, and we'll go into more detail about a lot of the back end and sort of preparatory work that's been done for this. It is scalable, but I think it's doable and it's replicable in other environments as well. But that, I think, is going to happen in January. Looks like January 2021.
Yes, and I definitely think we should make a plug for that. We're going to have Jim and Emma have agreed to provide a longer webinar on this, so that would be great. And then there's a question on, is this something you developed yourselves? Is that?
We worked with a developer from San Diego Supercomputer, where the workflow was really that Jim worked to describe kind of what the needs would be of the people using the data. I worked to kind of translate that into our version of a query and create really detailed requirements for the developer. And then we had meetings with him, and he kind of saw our vision, and we would go back and forth to make that happen. So it was kind of designed by us, and then he was able to make the technical elements with that.
And there's a related question, how many people over what period were involved in setting this up?
Good question. Over what period? We started working on this in March of this year. So not too long of a time period. And then with respect to who worked on it, it was our internal team. There are 4 of us. And then at San Diego, we worked with the developer as well as the architect for our data warehouse.
And I have a question for Sean Coady. I wondered also the lag time between, how much time between, for instance, a cohort collecting data questionnaire, do you expect them to deposit the data into your repository?
So our guidelines indicate that essentially the intent is to give about a 2-year protected time period. So say with an ancillary study, once that data has been cleaned and made ready for analysis, the clock kind of starts ticking. And approximately 2 years from that point, then it becomes widely available to the whole scientific community through the repository.
And what is, what kind of format? I noticed that the teacher's study comes in R or SAS in general. What kind of format is the data provided in?
So we are a come as you are repository, and very typically it is SAS. And so kind of on demand, we'll also convert it to say a CSV file or, you know, something that can be read by R. But very typically it is in SAS, but there's also essentially kind of like ASCII-based databases. But yeah.
Okay, thank you. Jim, you wanted to address further the question of upfront workflow?
Yeah, Roger and Nellie and Michael Jones, your question gets at it as well. One of the reasons I presented that overall picture of the CTS infrastructure is that this builds on everything we've done over the last 5 years, but at the same time, it doesn't require that much of an upfront investment. It's not dependent on anything there. Instead, the work we've done over the last 5 years has really helped us configure and design what Emma just showed. What you're seeing there is an relevant extract of CTS data, the survey data, the cancer data. As Emma described, it's modular, so if we want to add other data like hospitalizations or genetics, we can do that in the future. But we decided up front, based on the primary uses we were seeing, the primary kinds of requests we were getting, can we create a secure extract of CTS data and then configure a web application that talks with our secure controlled access environment? And so that, as Emma described, is a process that we configured and developed over the last 7 months. And the key people working on it were really Emma and the developer at the Sherlock Supercomputer Center. So this kind of approach, taking a NoSQL database and putting a web application on is increasingly common. We'll talk more about it in an upcoming webinar. But I just want to make clear that this is something that we think is achievable for other cohorts without having to spend 5 years in building a whole data warehouse and replicating the entire infrastructure that we've done in the CTS.
I'm not sure, Sam, do you see any more questions?
I believe those are all the questions. Yeah, I'll answer.
Then I have, I think we still have a little time. I'd like to ask one question of each of the speakers. How would a user request genetic and non-genetic data together? Sean, do you want to start?
I was kind of wondering if everybody's looking at me or not. Both genetic and non-genetic data for our ongoing population cohort studies, both are in dbGaP. With dbGaP and our ongoing population studies, typically, well, not typically, but there is a requirement that if you get it from dbGaP that you have a genetic analysis. So if it's non-genetic, then you're supposed to come over to BioLINCC to do the phenotypic type of research. Some of the studies within the repository, because some of the genetic was done, essentially ancillary. So what will happen is that ancillary genetic data goes into dbGaP, but all of the phenotypic data is in BioLINCC. And for there, we make sure that we can link the two should it be necessary.
Thanks. And Jim and Emma?
Should I take this?
Go ahead, please. Yeah.
For what we're working on right now, a big benefit to what I showed you is that modular approach. And so something we're working on right now that will be part of the December launch is having certain modules that will correspond to data domains that, even though they aren't self-service necessarily, that we can streamline the whole process and collect what people need within that app as well. So we will have a module to get information about things like biospecimens that people need, things like geospatial data, et cetera, so that we can make everything that's possible to be self-service, and then kind of have a flag for projects that will need a bit more of our person time to get that data ready and to join everything together. And so that's our plan, is to have that be incorporated and streamlined into this more automated process, but still acknowledge that there are certain types of data that will take a bit more effort.
I'd like to thank my colleague, Dr. Antwi, and the speakers for this session. Very informative. Thank you very much.
Thank you.
Thanks.
And then I'll turn it over to either Nanye or Marc. Gunter?
Yep.
Yeah. Go ahead, Marc.
Can you hear me?
Yeah.
Okay, great. So, hello everyone and welcome to this session which is on the European General Data Protection Regulation. So I'm Marc Gunter and I'm head of the section of Nutrition Metabolism at IARC, and I currently sit on the Cohort Consortium Steering Committee. And I'll be co-chairing this session with Dr. Joanne Elena from the Division of Cancer Control and Population Sciences at NCI. So as you've heard, sharing of data is crucial to the success of large-scale consortia projects such as those conducted within the NCI Cohort Consortium. But in recent years, there's been increasing scrutiny on how data is stored and shared, and the implementation of the new GDPR legislation by the European Union has brought a host of challenges in the sharing of European data outside of the European Economic Area. So we're now going to hear from two speakers who represent both the US and the European research perspective, firstly from Robert Eiss from NIH, and then from Dr. Giske Ursin from the Norwegian Cancer Registry, who've both been very actively engaged in trying to solve GDPR-related challenges and issues and ensure that European data can continue to be shared with non-European institutions. So we'll hear both presentations first, and then Joanne will moderate this questions, so please add them in the chat. So our first speaker is Robert Eiss, who serves as the Senior Global Health Advisor to the Director of the National Institutes of Health and the Fogarty International Center. Robert's been actively involved in navigating the impact of GDPR on NIH, and he'll outline the challenges that GDPR has brought to both US institutions and his views on potential solutions. So over to you, Robert.
Thanks very much, Marc. I know that this is a mixed audience with more or less understanding of the GDPR. So what I thought I would do was speak very swiftly or briskly about the GDPR provisions and territorial scope, discuss implications for the National Institutes of Health, and also signal some potential common resolutions that would be possible to help dismantle the stovepipes which emerged with GDPR. I think Giske, which will be the following presentation, will be able to provide us with an on-the-ground perspective on how to navigate and implement GDPR. Could I please have the first slide? Just very briefly, as many in this group know, GDPR was enacted in 2018 after May 2018 after a 2-year incubation period. It applies to the 28 member states of the EU, plus Iceland, Liechtenstein, and Norway, making up the European Economic Area. The United Kingdom passed the Data Protection Act in that same month in 2018, which mirrored the protections of the GDPR. So it's anticipated that the UK will be GDPR compliant post-Brexit. Very basically, GDPR tries to do two things. First is to confer individual privacy as an individual right. And the second is to harmonize privacy and data protection laws across Europe. It is considered the global baseline in data protection, and many countries from Brazil to South Africa are using it as a model legislation. Could I please have the next slide? Just to note the definition of personal data under GDPR, which is very broad and very supple, and that is any information relating to an identified or identifiable natural person. Next slide, please. Importantly, the scope of protection under GDPR is much broader than protected data under the Health Insurance Portability and Accountability Act, HIPAA, as well as the Common Rule. As many of you know, under HIPAA, if some 18 enumerated identifiers are stripped, it falls outside the regulatory scope of HIPAA. Anonymization data is not covered under GDPR, but identifiability is judged based on a probabilistic approach, a facts and circumstance test, taking into account all means reasonably likely to be used. I think that anonymization is so challenging in an era of data analytics and inferential analytics. The space monthly is constraining. Next slide, please. Very fundamentally, there needs to be a legal threshold for the processing use of data under GDPR, and there's 6 legal options which European institutions can choose from. this is a bit problematic because there's quite a lot of variability in terms of what institutions opting for different legal bases, which complicates multi-site trials as well as downstream applications. In addition, there are special exceptions that are needed for the processing of what is considered sensitive or specialized data, which includes biometrics, health, and genetics. Next slide, please. And most importantly, GDPR carries over many of the provisions of the European Data Directive, which I believe was approved in 1994. But the qualitative difference in what has created high cautions across Europe from the NIH perspective relate to the fines, which is up to 4% of global turnover or global revenue. I think the most visible fine was imposed by the French data authority, CNIL, against Google of some 50 million euros for constructing advertising profiles without user consent. Next slide, please. Importantly, for third country governments, GDPR requires a legal basis be in place to permit the transfer of personal data from the EEA, from the European Economic Area, to jurisdictions lacking adequate data protection legislation. There are a small cluster of countries that have been granted an adequacy decision by the European Union. These countries are able to transfer data without any prior authorization. But for others, such as the United States, they must fall back on what are called appropriate safeguards, an optional grouping of mechanisms, most prominently standard contractual clauses that have to be agreed upon before data can be transferred outside the EEA. This is the sticking point because there are no long-term transfer mechanisms that are viable for the US government or for many of its sponsored public universities. Our counterparts in the European Union are not concluding administrative arrangements or international agreements under Article 46. Standard contractual clauses, certification schemes, codes of conducts are not viable options for public authorities. And the so-called derogations, which are the exceptions to the rule, which could be used on a limited and time-bound basis, are not largely viable for US institutions based on the strict and narrow interpretations by the European Data Protection Board. So for third country governments, international transfer arrangements under GDPR are simply broken. Could I please have the next slide? I wanted to juxtapose very quickly two commentaries to note to sort of signal some of the issues with GDPR. Nature was quite prescient when GDPR was enacted in 2018. They warned against undue caution by legal departments across Europe in transferring data outside of Europe based on the lack of in many cases, interpretive clarity related to GDPR. GDPR has some 99 articles, some 173 recitals, which are explanatory notes. Not to be facetious, but the regulation is a bit like working through a William Faulkner novel with its circular construction. The provisions are all intermeshed. You have to continually cross-reference. It's a difficult regulation to interpret. In November of last year, Dr. Collins was interviewed by Science and related the data impediments that face NIH and its sponsored universities based on GDPR. So 30 months hence, nothing has practically changed, and we're still waiting for greater clarity and additional guidance from the European Data Protection Board, which represents the data protection authorities across the EEA. Could I please have the next slide? There's been one signal development. In July, the European Court of Justice ruled on the Commissioner versus Facebook Ireland and Hans Schrems. the suit challenged whether U.S. law regarding government access to personal data for national security purposes adequately protects U.S. citizens' privacy. I think they were focusing largely on FISA, as well as some of the executive orders that succeed FISA. As a result, Schrems 2, as it's called, invalidated the privacy shield, which was the transfer mechanism for commercial data exchange for organizations that self-certify and are regulated by the US Federal Trade Commission and the Department of Commerce. However, it upheld the validity of the standard contractual clauses for international data transfers, but it requires a new obligation. That is, institutions in the EU that transfer data under the standard contractual clauses now have to pursue an ex-ante assessment to judge whether the privacy laws and data security protections in the destination country are adequate. So they in fact have to perform, if you will, a micro-adequacy decision. Could I please have the next slide? I wanted to note some of the creative challenges and creative tensions surrounding GDPR, which makes this such a difficult regulation. As many of you know, in 2003 with HIPAA, the US imposed data privacy laws on some 20 to 30 years of human subjects protection, and many IRB members would indicate that there's still growing pains from HIPAA and its reconciliation with human subjects protection. But HIPAA, unlike GDPR, is sector specific, focused on health. GDPR is an omnibus regulation, and you can make the argument that biomedical research is caught in a metaphorical crossfire. The same principles that apply to commercial marketing and financing services under GDPR apply to publicly sponsored biomedical research. And I would say that is the core structural problem for third country governments of GDPR. Could I please have the next slide? Just to note the scope, I assembled just a sampling of projects affected by GDPR. And they range from GWAS studies through access to health outcome and epidemiological databases. I would say that the study on understanding the susceptibility genes related to type 2 diabetes between Francis Collins' laboratory at NHGRI and the National Institutes of Health and Welfare in Finland, THL, is the one instance where the NIH has been able to successfully conclude a data use agreement with a European institution. It's the only instance in the 2.5 years of GDPR, which is an indicator of the struggles that we're presently having. Could I please have the next slide? Just to note the scope, many of you know that NIH has a privileged authority. The agency can award direct grants to European institutions or allow its domestic grantees and contractors to award subcontractors in the European economic area. And if you did a census of the NIH portfolio, there are some 5,000 active projects with the EU presently. So the scope is theoretically extensive. The large fraction of these projects involve personally identifiable information. So the scope of GDPR and its implications is significant. It does indirectly regulate the processing and use of data collected in the EU for US institutions and sponsors. Could I please have the next slide? And just to note, I think it's important to note, especially in communications with the European Data Protection Board, the European Council, and the European Parliament, the fundamental implications of GDPR. This is the Mendelian Inheritance in Man catalog, which characterizes genotype-phenotype relationships, and it lists the disorders with known molecular basis and the numbers of therapies that have been developed to date. And it really does suggest the agenda of precision and personalized medicine in future years. I think that there's a need for the global scientific community to note and reinforce that, as this group so well knows, in biomedical research, sample size and diversity drive discovery. And as we more and more develop targeted therapies for subtypes of common diseases, as well as rare diseases, recruitment is going to need to be far more expansive, and collaboration with the European Union is increasing in its feature as a requirement of discovery. Could I please have the next slide, please? The major challenges and ambiguities, I won't go through this for the interests of time, but I would note that in addition to legal transfers of data outside the EEA, there are also differences in US and European regulatory interpretations of broad consent, with the European Union taking a far more restrictive posture towards future uses of research, as well as the data retention requirements, which present conflicts for US sponsors. When a subject withdraws from a study, the sponsor has the obligation to delete or fully anonymize the data. This immediately presents ethical and legal conflict for the US in terms of adverse event reporting, in terms of preserving the integrity of a clinical trial. And finally, the varying standards of anonymization across the EEA. In 1 week, an Icelandic institution will allow the US to receive pseudonymized data, providing the US destination has no physical access to the code. In the same week, a German institution refuses those same provisions. So there's a lack of a uniform risk-based assessment of identifiability across the EEA. If that were resolved, that would be a significant development in reducing some of these data stovepipes that have emerged. Next slide, please. And finally, some of the possible paths forward. One is to pursue a code of conduct that creatively reconciles differences in EU and US data privacy standards. I think this is a long-term and uncertain process, in part because it's unclear if a European citizen who feels his or her data has been breached in the United States would have adequate judicial redress. So it's unclear whether a threshold legal requirement could be met. Advocate for revisions in the standard contractual clauses, and I believe Giske will be speaking about this. The European Union has invited public comment on current standard contractual clauses. I do think that the solution may reside in a specialized transfer mechanisms for publicly sponsored or nonprofit biomedical research, seek a more uniform or workable definition of anonymization, develop template data use agreements and consent form clauses under current provisions, or develop platforms to share best practices, because this is very early on in the implementation of GDPR, but a best practice will emerge. People will discover creative workarounds. And with that, thank you very much. I know I worked through a lot of material very quickly, but look forward to addressing any of your questions. Thank you.
Thank you, Robert. So we'll move to Giske. So Giske is the director of the Norwegian Cancer Agency and professor at the University of Oslo. And she's taken something of the lead in the European population research community in trying to solve some of the issues around GDPR and data sharing outside the EU. So over to you, Giske.
Thank you. Can I have the next slide, please? I should first of all actually say that I'm not a lawyer, so you're getting the epidemiologist's point of view here. And then I would like to thank Robert Eiss, because 2 years ago, he talked about these issues at the NCI Cohort Consortium meeting. And although some of us knew that IARC was having problems in obtaining data from the European Economic Area after GDPR went into effect, we didn't know about the NIH problems. So next, please. So after that, a number of us got together and actually wrote 2 letters to the Lancet outlining both the challenges with sharing data outside of Europe, but also sort of stressing the fact that these data sharings, of course, must occur safely. Next, please. Now, Robert talked about the challenges with GDPR and a very strict definition of anonymity. And I would just echo that, would say that this is not something new. This is something that we have lived with for a long time, because these definitions were also the same in the directives. So we've had them for 25 years. Next, please. Now, just recently, though, this past week, a lot of things happened. So first of all, we just recently received these recommendations from the European Data Protection Board. And this outlines a 6-step roadmap for data transfer. And I'm going to go through these steps, particularly the first 4 steps in detail now for the rest of my talk. So these are quickly: first, know your data transfers. Second, identify the data transfer tool mechanism you can use. Third, assess whether the tool is effective. That means assess whether there are any laws of the data importer's country that may impinge on the tool. And fourth, identify and adopt supplementary measures if necessary. Next, please. So the first step is to know your transfers. And that's really for us data exporters to try and get an overview of who have we shared data with and what did we share. But it also affects you as the potential data importer. And there are 2 issues here. First of all, you need to know that this affects both direct sharing, data sets that we have sent, but it also affects remote access, wherever you have obtained access to data on a European server. Second, this affects obviously data sharing moving forward in time, so new projects we start, but it also affects already shared data, so ongoing collaborations. So don't be surprised if you suddenly start getting questions from your European collaborators on data sets that were shared years ago. Next, please. The next step is then to identify a data transfer tool, a mechanism. And this is where, as Robert said, we have to rely on the appropriate safeguards, Article 46 in GDPR. Next, please. And I don't want you to read all the text in this box. I just want you to see that there is a lot of text in this box, and there are actually a lot of mechanisms that have been proposed, and many of them may eventually become good mechanisms. But as of today, there are only 3 of them that we can really use, and they are circled here. Next, please. And this is because these are where we have the guidelines. So if we start looking at the green text, so this 2C, the standard contractual clauses, the SCCs, they have been around from 2001. If you are at a private institution, your institution signs these standard contractual clauses, you have a mechanism, we're good to go. If, on the other hand, you are at the federal institution, then we have a problem. As Robert just pointed out, this SCCs conflict with federal law. Now, we've been working through Robert Eiss. We've also been working with the General Counsel at NIH. And so we looked at the administrative arrangement together and these 2 other mechanisms. And we also identified, or they identified, where these conflict with US federal law. Now, we have reported these conflicts to European Data Protection Board in the hope that they'll help us find solutions. And you should also know that IARC has the similar challenges with these different mechanisms. Next, please. So what are these specific challenges? Well, there are several, but I'm going to list 2 of them. So one is the archiving laws in the US that conflicts with GDPR. So if European law requires that data have to be deleted on a data set that have been shared with the US, then US federal law could stop that. And that gives us a problem. Second challenge, the redress issue or indemnification issue. So let's just assume, although unlikely, let's just assume that there were to be a really severe security breach at the federal US institution involving research data. And so that some of these people actually had their sickness history somehow publicized. Now, if this affected US citizens, then they could actually go to court. They could take the US government to court. But European citizens, that is non-US citizen, non-US residents, cannot take the US government to court. So they cannot get any sort of redress, any indemnification for this damage that has occurred. And this is a challenge. Now, we were hoping that the standard contractual clauses that are now being revised, we were hoping that they would take care of these issues. And they just came, I got them Saturday, late evening. But they don't really address them. So how do we solve this? Next. Well, we think that there is a solution, but we have to try it out on our data inspectors, and then we have to see what the NIH lawyers think. But we think that we could get around this by providing access to NIH researchers by giving access remotely to European data on a European server, and that we could combine this with an Article 46 mechanism. So we will see if we can get around this, but at least we're willing to try. Next, please. So let's say now that you have a mechanism. For example, you are at a private institution, so you have this standard contractor clauses as a mechanism. Then the new thing now is that we have to do an assessment. We have to assess whether this tool is effective. So will any laws or practice impinge on the effectiveness of this transfer mechanism? So these are some of the strange questions that you might now suddenly get if it turns out that we think we can go ahead with this transfer. We will ask you, which federal or state laws apply to you, to your institution, that would impinge on the SEC requirements, if we're now using SEC as the transfer mechanism? So obviously you're going to refer us to your lawyers. And the next question, and this I thought was really interesting because this is actually a big deal in GDPR, the focus on mass surveillance laws. So we will ask, what relevant previous experience do you have with requests from your public authorities to disclose data, to disclose research data? And yes, this is something we will ask. Do you have any such previous experience? If so, what data did you release? And then finally, we will ask a bunch of questions about storage of data. And if you answer that you're going to store it on the clouds, then we have some additional questions because that's also sort of an impediment when it comes to GDPR. These assessments, we as a data exporter will have to do on a case-by-case basis. And obviously it requires close collaboration with lawyers at the data importers recipients institution. And this is what I was referring to, that you might start getting questions from your European collaborators where the data are being analyzed right now. Next, please. So now we've gone through this assessment and perhaps we've concluded there are some challenges. Well, then we go to step 4. Identify supplementary measures if needed. So this is needed if the data exporter, our assessment, is that the legislation in the data importer's country impinges on the effectiveness on the Article 46 transfer tool, then we have to see what kind of supplementary measure can we use. So here are some examples. Encryption when we send the data, that's one example. Now, this is important and we always do that now when we send data, but the thing is that it's really insufficient as a supplementary measures here because the criteria for the encryption, they're so strict that very few institutions in Europe will actually be able to do that. But then we have pseudonymization. This is our de-identification process. And I think this is where the key is. Next, please. So again, I don't want you to read what's in the black box on the left. You can look at my interpretation, which is the blue box on the right. So the key here is the de-identification techniques that we use. Strong pseudonymization procedures are really, really important. So let's now assume the identifiers are removed on the data that we send. We always, of course, remove the identifiers. But let's also assume that the individuals are not identifiable from the data alone. For example, we're not going to give you detailed occupation and say that the prime minister had something, a mole removed in 2010, right? So the data cannot identify individuals alone. And second, the code and key needs to be safely kept by the data exporter. And they mean really, really safely kept by the data exporter. And then in addition, the assessment has to be done that the public authorities in the recipient country do not have sufficient other information to link with this data set that would render individuals identifiable. Now, the way I interpret this is that we have to just make sure that we do not publish openly detailed data from any of these populations. Because the moment there's a lot of detailed data on various populations openly out there, then, yes, if you start merging all these data, perhaps then data become identifiable. But as long as we make sure that we share the data securely, then we are also okay on 4. Now, if we can do all this, then we're okay. Then we're good to go. Then pseudonymization is an effective measure. And then the lawyers will say that we'll have a little bit of issue with genetic data or very detailed data. And I'm sorry about the lightning, but it goes off if I sit still. Next, please. So some of you are now really impatient and you're thinking that you're done with Europe. You don't want to use European data ever again. But then I beg you, please don't think that way. Because here's the fast track solution for those of you who already have the grants. You need to start analyzing the data right now. Well, the solution is let the syntaxes travel, not the data. So harmonize the data using the code books, using the data dictionaries. And when you come to analysis of data, well, send the syntaxes to the European institutions. And if you can't deal with it because there are too many of them, well, tell them that they have to agree on who's going to be the European node and ask them to then have all the data analyzed there. And one example here is in the PREDICT consortium, in the Ovarian Cancer Project, Heidelberg is doing the analysis for the European centers. And then finally, and this is not a great suggestion during a pandemic, but it is perfectly possible to send the researcher to Europe, not to IARC, but to the European Economic Area to analyze European data, because that's safe. If the person comes to us, analyzes the data on our European infrastructure, then we're good to go. Next. And the European Science Academies understand this problem, and we're working on a report right now to try and also find solutions. Next, please. And so in conclusion, I just want to say that data sharing is possible. Yes, it's burdensome. It requires these steps, 2 to 4. It requires a mechanism. It requires an assessment. It requires the supplementary measures. But finding the mechanism, straightforward if you're at the private institution, you use the standard contractual clauses like we've done the past 20 years. Federal institutions is more challenging. Public institutions, I'm actually a little confused right now because there's some of them that still sign them and some of them that do not. When it comes to the next 2 steps, the assessment is possible to do, and the supplementary measure, step 4, I think this is really doable. Now, we have to perhaps though keep in mind that the alternative for all data sharing moving forwards, it might be that we'll end up with the following, that we'll analyze the European data on European servers, US data on US servers. So that might be the most viable in the long run. Now, what I can promise you though is that at the Cancer Registry and at the Janus Serum Bank, we are going to continue working on this because data sharing for us is really, really important. It's important for us that people use our data. And so these images here are from the area just outside of Oslo. And this is where we go also during the pandemic in the nature to ponder these questions and to ponder research questions. So come and visit us whenever you get the chance. And if you'd like to stay a little longer, we are also hiring right now. So thank you very much for your attention. I'm happy to answer any questions.
Thank you both. These were, oh, sorry, Marc, these were wonderful wonderful talks. And Giske, those pictures, I think you may have just successfully hired some people. And there's no chance of us giving up on European data. So we will definitely make this work somehow. My first question for you is, for both of you actually, does individual consenting help in this process? Is there something that you can get participants to do that may assist?
I could begin. Explicit consent actually is one of the derogations under the GDPR. So conceivably, if you, in your consent document, if you indicate to a data subject that his or her data will be transferred outside the EEA and also categorize the risks of transferring that data to a country without an adequacy decision, then you can use that, then consent works on an exceptional basis for GDPR. The problem in moving forward, this is a feasible option, but it becomes impractical to go back and reconsent study volunteers. So I think it's a half measures only. But might also have a perspective on the use of explicit consent under Article 49.
No, I completely agree. And what we're seeing is that they're very strict with what the wording in the consent should be. So if there's a consent from before 2018, forget it. And even the consents that came right after 2018 went into effect, they weren't really strong enough.
Great. There was a clarifying question about whether or why you may see the cloud as an impediment to the GDPR.
Okay. This is a complicated legal question. Robert, would you like to start?
I know it's very diverse across Europe. I think some countries don't allow data to be stored on Amazon Web Server, for example. So I think there are different provisions and requirements in each country, and we're learning more as we go along. But practices will differ not only among countries, but within institutions in the same country.
I think what became clear this summer is that if it would be a European server and everyone providing services would also be European, then it would be good. But the problem is that, you know, the biggest technical platforms, they're US providers, or they have some sub providers that are US providers. So I think that's where the problem is.
Yeah, you know, I think what we're seeing, the state of play is distributed analysis. That is that research teams in the United States and Europe are doing identical analyses and then pooling the analyses in summary meta-analysis. And that is such a compromise in terms of cost, in terms of delays, and in terms of limitations on the number, utility, in terms of the number of research questions that can be posed. But that seems, apart from remote access, that seems to be the only creative and limited option that's open to many institutions in the US, from my anecdotal understanding.
Marc just had a great point here. He has helped us with a metadata repository that we have put together called the CMR that has harmonization code across cohorts. So it seems to me it could be possible you have your European-based servers, your US-based servers, and you could be running things simultaneously, and that may be helpful in harmonization. Eventually, things have to be combined. And there's someone raised the point of rare cancers. How ultimately, I'm sure you've thought through this, ultimately, how do we bring things together? Can we?
Yeah, so this is the real tricky issue, right? And sometimes it's not really that easy to harmonize using data dictionaries either. So sometimes you really need to pull the data together to understand how to actually look at it. So that's why I think we keep plugging along to see if we can, how can we actually manage to get these data sharing up and going. And I think in the meantime, you know, keep in mind this, okay, outside of after the pandemic, yes, it is possible to send a researcher to Europe.
I think that's eventually, hopefully we can. I would love to travel again. So let's see. So there are a few questions here about maybe, do you think there might be interest in getting a group together through the Cohort Consortium, perhaps, that meets every so often to discuss how they've navigated this issue? And second, I had a question, just a practical one for either one of you. Do you sort of have a go-to, when you have questions, is there a website? Is there a place that you go that is your first pass for information?
So I can tell what we do. We have a network of lawyers and we consult with them, and we also then consult with the European lawyers that we know. So, and sometimes also commission lawyers. That's where we go to. I think that for your first question, to have a group that work on this would be really useful, because what we're seeing now is that some of these questions that we learned last week that we're going to have to ask our colleagues, and the ones at the private institutions are going to be the ones first out. We have 2 such contracts that we're dealing with now. And what we learn from those would be very useful for everyone else, right? So I think to have a group, but we need to have some people at private institutions who are dealing with this right now, because we could all learn from each other.
Great. Additional question about whether IARC might be able to provide the European server. And actually IARC, IT, you may be setting up a system as right now. So that might be an option until we can have people travel, or if traveling is not possible.
I'm sorry, Pietro. No, that's not possible, because we have exactly the same challenges with sharing data with IARC. That's a real problem now. Now, IARC has been working on this for a number of years. I was on the scientific council a few years ago, and they were already working on this. Now, I know that they're working very closely with the European Commission to see if they can set up agreements, but this is a really impediment for IARC. But if IARC were to go out of their building and cross the street into an institution that's in France and not an international organization, then they have solved that problem, but not at IARC.
Not at the moment, anyway.
Yeah, so nuanced. Yeah. Okay, so there are I'm sorry, Marc, were you about to ask a question? Okay. From Larry Cushy at Kaiser, there are efforts underway to conduct distributed data analyses across different data repositories where data do not need to be combined, but result in similar results as if the individual level data were combined. Perhaps this should be explored as a possible approach to analysis. It would require data harmonization, but different from meta-analysis.
I can just say that there's a number of efforts ongoing in Europe as well. We have a collaboration with the Dutch Cancer Registry, where we're also trying to do some distributed data analysis. So I think that Larry has a good point. This is a way to go.
Great. Another suggestion for common code with annotation of details that could be applied to different data, which I think everyone's got that same idea. It would be, I think the bottom line is it'll be great to bring this group together to meet and combine tips. Anything, we have 2 minutes left. I'll keep asking you questions, but anything that you have to tell the group that might be helpful going forward that may have come up since you spoke?
I think that this is a very, I'm sorry, go ahead, Robert.
Oh, you know, I would only note from the NIH perspective that we're making active efforts to our State Department to hold a consultation with the European Data Protection Board to elevate these issues and pose what we feel might be some potential remedies, because there's a sense, an imperfect sense on behalf of many of my colleagues that the Commission, as well as the European Data Protection Board, don't have a close enough understanding of the decisions that are made daily by legal officers across Europe, that they're somewhat once removed. And we think that there needs to be thoughtful advocacy and communications with Europe. And even, I mean, one potential is that whether in the next administration, the US government will decide to pursue an adequacy decision. And I think the prospects of that might be increased given the fact that the privacy shield has been invalidated. So I think the private sector is going to put some downward pressure on the federal government to find some type of to pursue some type of equivalence decision with the European Commission. So in the next half a year, things might relax somewhat, but that's just speculation.
If I can just add one thing there, and that also keep in mind that that private companies are now moving over to standard contractual clauses, and they're already, you know, addressing some of these, helping us address some of these assessments. So I think that my concern would be that they actually find the one mechanism we have today and they use it. But I really hope that you're right, because if you could get an Article 45 adequacy decision for the US, that really would really help.
And just to note, Giske, it could be a sector-specific adequacy decision as well. It doesn't need to be as broad-based, which would simplify things somewhat.
Okay, and I'll leave with one optimistic note, a positive spin on the COVID-19 epidemic, saying that maybe it's helped relax some of the data sharing barriers in the UK, and that we should push on while the iron is hot. I don't know if that's entirely true, but I will thank both of you for a wonderful session. This is